Welcome. Let's look at sum and difference formulas. This page shows most of the trigonometric formulas and identities that someone needs in trig, and we are going to focus on these sum and difference formulas. Now, very important thing on this is to notice that in this paper, in order to fit it onto one page, there's an issue with the pluses and minuses. They did that. So if I unpacked this, I would have that the sine of alpha plus beta would have a plus in the middle of the formula. So it'd be like this. Sine alpha plus beta would be equal to this part, but with the plus only. Sine alpha cosine beta plus, oops, it's cosine for leading off the second part. Cosine alpha sine beta. So sine gets used twice as alpha and beta with it, and cosine gets used twice, alpha and beta, just the beta comes first. Now, that plus then matches this plus. And if the first one had been minus, then the one in the formula would be minus. With the cosine, it's a little different. So the cosine sometimes is a little tricky. So here's where it is. So let's take the cosine alpha plus beta, and that's going to be equal to, following this, cosine alpha, cosine beta, so no signs yet, but then notice this plus and minus is upside down. That means that if I use the first one from here, I use the top one, then I use the top one here. So that means that this plus means a minus in the formula. Sine alpha, sine beta. So that's the weird thing on the cosine one, is that the sign switch. Now notice that for the tangent, if we have plus leading off, then on the top we'll use plus, but on the bottom we'll use minus. And if it was the minus being used, then we would be using the minus and then the plus on the bottom. So tangent partly goes normal on the top, partly is normal on the top, and partly is not normal, opposite of what you would think, on the bottom. So be aware of that as you do the different parts of the formula, or as you use the formula. So let's go look at a couple of examples of how to use the sum and difference formulas. Find the exact value of the sine of 75 degrees. Well, exact value means use the unit circle and keep things like square root of 2s or square root of 3s or other square roots. Don't make them decimals. That's what exact value means. Okay. Or if it was like 1/3, you can't do 0.333 because you'd have to round. So no decimals. Keep them as square roots if they're supposed to be. All right. So let's take a look at what happens with this. I need, what would help most is to take that 75 degrees and rewrite it, sine of two things that add up to 75 degrees. And in fact, it's not that hard to do if you think of the fact that you can have a 45 degrees and a 30 degrees. Those two would add up to 75. There are others that would add up to it also. However, those may not be on the unit circle. So these two being on the unit circle, we can get exact answers. But what I have is a sine of adding two angles. And that means I'm going to use the formula where the sine of theta, actually it's sine of alpha plus beta is equal to sine alpha cosine beta plus sine beta cosine, oops, wait a minute, other way around. It would be right, but I just switched to here. Cosine alpha sine beta. So now let's put the numbers in. This is 45 and this is 30. I'll switch to purple for this one. So that's going to be the sine of 45 degrees, the cosine of 30 degrees, plus the cosine of 45 degrees, and the sine of 30 degrees. So now we simply find what they are. On the unit circle, sine of 45 is square root of 2 over 2. Cosine of 30 degrees is square root of 3 over 2 plus cosine at 45 is square root of 2 over 2. And the sine of 30 degrees is 1/2. Actually, that's a parentheses, that's a parentheses. Okay. Now I multiply them together, and that's square root of 6 over 2 plus square root of 2 over 2. And although that's mathematically correct, it would be better to put these together because we have the same denominators. So square root of 6 plus square root of 2 over 2 is the best answer. So what we did is we had to find a way to add up to make the 75. Then we used the formula with putting in for alpha and for beta, alpha and for beta. And then putting in these things from the unit circle. Let's do it now with a negative. Find the exact value of the sine of negative 75. Okay, now, actually, this has been changed where this is difference. And this is now cosine. I changed it because I want to use one of the cosine formulas to practice with changing around the signs from what you'd expect. Okay, so we're going to do cosine here. I'm going to write cosine. C-O-S, cosine. So I want to take the cosine of 75 degrees, or negative 75, cosine of negative 75 degrees. Now, one way to do it is to take 75 and like play with numbers that would make 75. So for instance, we know that 75 would be equal to 45 plus 30. Well, that means if I made it negative, I could just make these two negative and I would get that too. So I could do negative 45 and negative 35. Okay? However, we would have to, for the purpose of putting the formulas, we would have to do it as seeing that A is negative 45 and that would be minus 30. So we could use the negative formula, but the negative 45, we want to go backwards and see it as the 315 degrees that it is for the normal direction counterclockwise around the unit circle. So we want to try to keep to counterclockwise around the unit circle. So there are a number of ways that we could write this one, but let's try this. Cosine 45 degrees subtract 120 degrees. 45 and 120 are on the unit circle. And because that 120 is like in parentheses, if I'm going to use the cosine of alpha minus beta for my formula, then that means the 120 is positive. I could have done something like this, okay, but not for this problem. However, let's think of this. 45 plus 120 degrees, cosine 45, that plus is actually minus a negative 120 degrees. So we could use a negative 120, but you see the problem with this is we're trying to get to negative 75 and this adds up to 165. So that means that this is not what we want to do. I just wanted to show you that you could use two negatives or switch the positive and negative. Maybe that's the better way to put it. Cosine of 45 degrees plus a negative 120 degrees. So this one would actually work for this problem. So I would use a cosine of alpha minus beta, but I would have to, plus beta, but I would have to figure out where negative 120 is, and I would actually see that that's 240 degrees. So I would have to use 240 for my unit circle alpha and beta, or actually that would be my beta, because negative 120 and 240 are the same. So I'd have to change that. However, I'm not doing any of those. I chose to do this one. I chose to use a difference formula, and that's why I changed the title of it to use a difference formula. So for the difference formula, cosine alpha minus beta is equal to cosine alpha cosine beta plus sine alpha sine beta. So both cosines come first, and then you add the two sines. So using the unit circle then, or actually let's now do that, that's 45 and that's 120. So we have is the cosine at 45 degrees cosine at 120 degrees, plus the sine at 45 degrees, and the cosine at 45 degrees. Well, let's put these in the unit circle, or use the unit circle. That's square root of 2 over 2. Now, cosine at 120, that's in the second quadrant, so we get a negative answer here for that one. Plus the sine of 45 is square root of 2 over 2, and I just realized I wrote this wrong here. So let's fix that. That would be sine of beta, because I have cosine, cosine, I have sine and sine, and I have to use each one with each thing. So that would be 120 degrees. So over there to the side of 120, sine at 120 is square root of 3 over 2. So I have a negative for this one, negative square root of 2 over 4 plus square root of 6 over 4. And because the 4's are the same, we can do negative square root of 2 plus square root of 6 over 4. We cannot put the negative in front unless we were to do square root of 2 minus square root of 6 over 4. That's because if I take the negative from the top, I have to take it from both things. So I would have to do this kind of thing. Negative square root of 2 minus the negative square root of 6. So I'd be taking a negative 1, or I guess you could say I'd be taking a negative 1 from here and a negative 1 from here. And that would still then be a subtraction. It's easiest just to leave it this way. So here on this one, I had to rewrite this in some form with, in this case, directed to as a difference. I had to make a subtraction. And then I just used the formula, plugged in the degrees and the appropriate sine or cosine, and then could add them or subtract them together. Let's take a look now. We're doing the same thing, but this time let's find two different ways to rewrite negative 165. So there is negative 165. So I have to think, what would give that to me? So I have a couple of possibilities here on this. I could do 45 degrees minus 210 degrees. That would give me a negative 65. I can do 60 minus 225 degrees. I can do 240 minus 405 degrees. So I have like three possibilities right here, right now. Right? I could even do something like, as says, or a difference. These are all subtracting. I could do this as 240 plus a negative 405 degrees, right? Although I probably want to stick to, having the 405 come around back within 360. So I could take this one and do 60 degrees plus a negative 225 degrees. And negative 225 would give me 6135. Yeah, I guess that would be 135, which is on the unit circle. So that means I would use 135 when I'm looking on the unit circle for the parts of that one. Well, I'm going to stick to the first one that I have here right now. So I'm going to say that the sine of negative 165 degrees is equal to the sine of 45 degrees minus 210 degrees. So now let's use that with the formulas here. So that means that this will be alpha and that will be beta. And sine alpha minus beta is equal to sine of alpha cosine beta minus cosine alpha sine beta. So the negatives match up here in this case. So let's go ahead and plug in that if that's 45, and actually alpha is 45, and beta is 210 degrees. So that's equal to the sine of 45, square root of 2 over 2. Cosine at 210, that's a negative because it's in the third quadrant, square root of 3 over 2. Cosine of 45 is square root of 2 over 2. And the sine 210, well, that's also in the third quadrant, so it's a negative 1/2. And so now let's put these together. Negative root 6 over 2. Oh, not 2, 4. Minus, oh, look, this is a minus and that's a minus, so they cancel to make a plus. Square root of 2 over 4, which is equal to negative root 6 plus root 2 over 4. Or if you took out the negative from the top, you could have negative for the fraction, but it would be square root of 6 minus square root of 2 if you did that. But both of those are equally valid answers for this problem. Okay. Now let's take a look at a couple more problems to verify identities. And here's one. Let's go to this problem. Pi minus theta. Okay? One thing is you cannot distribute. So doing that and doing that, you cannot do in these. These are functions, not calculable numbers in front of it. So we're not going to distribute. Instead, what we're going to do is we're going to use a formula for it, because this is an alpha minus a beta. So we can use a difference formula. And if we're going to verify identities, let's work on one side. And let's start off with finding the formula for this. So cosine alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. So this is minus, that's plus with cosine. Now let's put the numbers in it. Cosine pi cosine theta plus sine of pi sine theta. Well, theta we don't know, but we do know what the cosine of theta is. The cosine of theta is -1. Oh, not theta, the cosine of pi. The cosine at pi, which is 180 degrees, is -1. Plus, the sine at pi is 0 and sine theta. So this just goes away and we get a negative there. We get negative cosine theta. Oh, guess what? They're equal. We just verified it. And what I had to do, all I really had to do was to use the right formula and plug the things in, and then I had to use the unit circle again. And so we have verified that identity. So let's do a different one that's a sine one that now will have a number. That's done with pi. Now we're going to do one where it's got 360 in it, like 2 pi. And we need to see, can we get that equal to sine of theta? So let's use that this is alpha and beta. And the sine of alpha plus beta would be equal to sine of alpha cosine beta plus cosine alpha sine beta. So by numbers, that means 360 degrees times the cosine of whatever theta is. Cosine of 360 degrees. And then the sine of theta. So 360 degrees, the sine at 360 is a 0. The cosine at 360 degrees is a 1. So 0 times that means it's just 0. And 1 times the sine of theta is the sine of theta. And oh, guess what? We just verified this identity. Wow, it really boils down to all of it going away except the basic thing that you need. So I just verified it. So that in the future is what you'll do sometimes, is whether it's verifying an identity and using the sum formula just because of the fact that you're given two angles that add up, or subtract in this case. Let's see, where was I with the rest of the saying? Okay. Using this one, so think about the things that we did here. It's really just getting the right formula, putting the numbers in, and getting the actual cosines and sines, and then adding them all up. So using just those sum and difference formulas with sometimes the reciprocals or tangent cotangent ones gets you through a lot of these kinds of problems. I hope this helped in understanding this section. Thank you for watching and listening.